In this video, we're going to take a look at Redis sets. If you're not familiar with sets, sets are an unordered collection of strings. And one of the nice things about sets is you cannot have repeated members within a set. And what that means is that you can't have duplicate strings within a set. So everything has to be unique. Let's take a look at some of the functions you can do with sets. So to add an item to a set, it's super simple. It's just the sadd for add to set, the key of the set you want, and then the member. So let's create a set of fruits, and let's go ahead and add an apple to that set. And you'll see we get back an integer of 1, which means that it's worked correctly. To list out any members within a set, you just do smembers, and then the key of your set. So in this case, fruits, and you'll see we get back apple. To add multiple items to a set, again, you can use the sadd command, pass in the key of your set, then just add multiple members to your set. So let's add pear, let's add blueberry, let's go for strawberry, and let's add fig, and let's add cabbage, which isn't a fruit, but we'll get onto that in a second. So you'll see we get back an integer of 5, which means we've added 5 items to our set. If we go ahead and have a look at the members of our fruit set, you'll see we have all of those items in there now. We've added cabbage, which, as we know, isn't a fruit. So to remove that, it's quite straightforward. It's just the srem for set remove, and you pass in the key of your set and then the member you want to remove. In this case, cabbage, which will remove that. We get the integer 1, which shows it's been removed. If we go ahead and do smembers again on our fruits set, we will see that we no longer have cabbage within our set. As I mentioned earlier, sets can only have unique members within them. So if you look at our fruits set, you'll see that we currently already have a pear within that set. Let's go ahead and try and add a pear again and see what happens. So sadd fruits, and then we'll try and add a pear again and we'll see what happens. And what happens is we get back the integer of 0, which means that nothing has been added to that set. And if we have a look at the set again, we will see that we only have 1 pear within our set. If you want to find out how many members your set has, you can use the scard function for cardinality, and then you pass in the key of your set and you'll get back the integer of the number of items within your set. So our fruits has 5 items, and you'll see we've got back the integer of 5. To find out if an item exists within your set already, you can use the SIsMember function. So again, you pass in the name of your set and then the item you want to check. So let's check if we have fig in our fruits set, and you'll see we get back the integer of 1, which means it does exist. If we go ahead and do the same check, but this time we'll pass in basil, which isn't in our fruits because it's a herb, we'll see we get back the integer of 0. The SIsMember function allows you to check if something exists within your set. I'm going to go ahead and create a new set called red fruits, which we're going to use to do some of the commands that you run on multiple sets. So in our red fruits, let's add apple, strawberry, and cherry. So we've created that set. So now we currently have a set of fruits, and we also have a set of red fruits. The next command we're going to have a look at is the sdiff command, which allows us to get the difference between the first set and then any successive sets. Let's check how many fruits exist in our fruit set that are not red. So we do set fruits, and then we'll compare that, get the difference from our red fruits set, and you'll see we get back all the fruits that are not red. So what the sdiff command does is it takes your first set and then any sets beyond that, and it will grab the items from your first set that do not exist in any successive sets. In this case, we've got back all the fruits in our fruit set that are not red. And you can run this command on multiple sets. So if you go ahead and create a new set for blue fruits, and we'll just add blueberry to that as well. And then if we run the same command again and pass in our blue fruits as well as our red fruits, we'll see that this time we just get back fruits that are not red or blue. If you want to store the difference between the sets that you're comparing, you can do that with the Diff Store command. You pass in the new key of the set, so the destination set. So in this case, we'll do non-red fruits. and we'll pass in our fruit set, and then we'll just do that with one set for our red fruits, and we'll get back a new set of 3 items. And if we do SMembers non-red fruits, we'll see we get back all the non-red fruits. If you want to store the value as your sdiff command, you can do that with the SDiff command by passing in as the first value the destination set. The next command we're going to have a look at is the SInter command, which gives you the intersection between sets. So if we just have another look at our sets, so we've got fruits, and then let's have a look at the red fruits set. So the only fruits that are in intersection here are apple and strawberry. And if we want to find those ones, we can go and do SInter. We pass in the fruits and then the red fruits set, and we'll get the items that intersect between both sets. So the items that exist within both sets, and you'll see here we've got strawberry and apple that exist within both sets. As with the SDiff command, there is an SInter command that allows you to store the return value of the SInter command. So we'll go ahead and do that. SInter. We'll do this really red fruits, pass in our fruits and red fruits sets, and we'll see we get back an integer of 2, which means we have 2 members within our really red fruits set. The next command we're going to have a look at is the SUnion command. So before we do that, we'll just have a reminder of what exists within our sets. So in our fruits sets, we have pear, apple, blueberry, strawberry, and fig. In our red fruits set, we have strawberry, apple, and cherry. If you want to see a union or a combination of all of the members within your sets, you can do that with the SUnion command. So you pass in the keys of the sets you want to combine. In this case, we'll do fruits and red fruits, and you'll see we get back a unique list of all of those members. And as with the diff and inter commands, there is an SUnion store command. So we'll do all fruits, and then we'll pass in the fruits and red fruits sets, and we'll get back a new set of all fruits, which has 6 members. The final command we're going to have a look at is the SMove command, which will allow you to move a member from one set to another. Let's go ahead and create a new set of vegetables, and we'll just add cabbage to that set. And then we'll go ahead and add something to fruits. Let's add lettuce, which as we know is not a vegetable. So we want to move lettuce from the fruits set to the vegetables set, and we can do that with the SMove command. The first key is your source, so in this case fruits, as that's where lettuce currently exists. We want to move that to vegetables, which is going to be our destination, and then the member is going to be lettuce, and you'll see back we get an integer of 1. Let's go ahead and do an SMembers of fruits, and you'll see we have no lettuce there. And then if we do the same thing for vegetables, we should see that we have both lettuce and cabbage. And that's how you move a member from one set to another. Thanks for watching. Don't forget to like, share, and subscribe. It really helps out the channel.